Hello there. So, another video, just going to be a bit short, 2 minutes or so, and I'm just going to talk a little bit about space and more importantly, what I care about in space. So, basically, I'll be talking about stuff like, space propulsion technologies, what we can do in space, space hotels, space tourism, and some of the stuff that SpaceX is doing. Right, so the first thing is there is going to be a revolution, the space revolution, and it will be started by SpaceX, Blue Origin, NASA, all these private space companies, by China, by the US, by basically any country that goes to space and any companies that go to space. Now, after the big space revolution, we're going to start exploring Sol and the solar system. Now, to get things straight, we call the sun solar and all sorts of things, and we call the moon lunar. And this is based on the one that the Greeks and Romans called the sun Sol, and or based on gods and stuff. I think the Greeks the Romans called the sun Sol, and they called the moon lunar, and the Greeks called the moon Selene. So I'm just going to call the sun as Sol and the moon as lunar. So once we start colonizing Luna, which we can do right now, we can colonize the moon. We have the technology. It just takes a lot of funding and, more importantly, expertise. A lot of these people in NASA don't always have the right expertise because what they're doing is really hard. It's difficult. It's not easy. I mean, we do things because not they are easy, because they are hard. We climb mountains. We explore the deepest bottom of the oceans. We create technologies never seen before. We explore quantum physics. We do the hardest of maths. I mean, there is this person who's learned pi to 28,000 digits. There's people who've learned maths to extreme extents. They've learned the times tables to the thousands, not the tens. And it's ridiculous that some people seem to think that this is not why we do things. And the thing is, at the moment, for corporations, they don't benefit from that. They don't benefit from people doing whatever they want. They benefit from people simply doing what is easy. And we shouldn't do things because they're easy. We should not become the society of the easy people, the society of the lazy, the society of the soft sinners, of sloth. We should not allow sloth to become the sin of our society. We should instead work hard. We should be diligent. And this is one of the reasons why, even though I'm not religious, even though I'm at least at the moment agnostic, I think that religion can do good things, because the 7 deadly sins and the 7 virtues did improve society, and that is definitive. You cannot argue with me on that. That is just proof. I mean, change my mind or something later. So, once we start going into space, the next big thing will be space tourism and space hotels. I mean, imagine going to space and having your own room that's in low grav. Imagine being able to jump. Imagine being able to take liquids and look at it. Imagine being able to do all this cool stuff. I mean, would you pay £60,000 for that? Because if SpaceX gets their rockets to fly 1,000 times reliably, and then they can get it so that their Falcon Heavy rocket can take, let's say, 20 people for launch, and they will make this as reliable as possible and as effective as possible, and they use Dragon or something, and they can make it cheaper and cheaper. So 1,000 launches for a Falcon Heavy, and then they send 20 people there, and it costs I think it costs 90 million for SpaceX. It costs 120 million for NASA. So let's say it's 120 million because it's more expensive to be safe. So you have 20 people divided by 120 million for 20 people. That's about so that's 120 million. My bloody adverts. 120 million for, so divided by 10 is, that's 12 million. Then it's 6 million. So each person will, if to buy the rocket as a whole, each person would have to pay 6 million. Now, to be able to fly the rockets, if they fly the rocket 1,000 times, then that would be 6,000. So it would cost £6,000, according to SpaceX's future predictions, to safely go into space using Dragon and making it extremely successful using the NASA protocol. And that's using oil, or kerosene rather. So think about that for a moment. You could go to space for, well, about how much it costs to go between countries using the current I think first class. So you could going to space will cost as much as it costs right now. When SpaceX starts making a company out of this, it will cost as much as it costs all business. As it costs you to fly to another country at what do you call it? You know, my mind's going blank today. It really is. It's like someone's attacking my head. Don't have any water. Okay, that's it. I'm thirsty. I left my glass downstairs. Okay, I'll talk on this with a low amount of H2O and oxygen. So basically, it'll be like going to a different country first class. It will be expensive, and there'll be only a few people on board, but it'll be quick. You'll go to space in 10 minutes and go into the space hotel. And then the next big step will be what you can do in space. I mean, think of all these different things in space. You can watch the world spin around. You can prove to people who believe the Earth is flat that it's not. You can look at Antarctica. You can look at climate. We can study climate so much better. I mean, all these different things, all done by a single company, and it's so amazing. I mean, has no one ever considered this? I mean, just do the maths. If SpaceX can go to space 100 times per Falcon Heavy, and it cost 90 million instead of 100 million. So let's say it's ran up to 100. Then let's say they can only do 100 times. And that's 1 million per launch. Now let's say they can get 50 people per launch. That will be 100,000 divided by 5. My maths is really bad. That'd be £20,000 for a single person in the next few years in the future to go to space. And it will get more cheaper as they can increase the reliability. But that will be how expensive it will be. And is that not amazing? I mean, what SpaceX is doing is so amazing. And it's such a shame that the only company that's doing there's only a few companies doing what they are. There's only Blue Origin, really. There's none in Africa. There's none in India. I mean, the government is doing projects in those countries. But there are no space corporations. And we need space tourism. Space tourism is the next big thing. Because, one, you don't have to worry about rubbish as much because it will just burn up and re-enter Earth and will just disappear. I mean, people talk about how there are all these different stuff in space that could cause damages, and that's why they have to build space stations so strong so they can survive. But the truth is, you could just use magnets to protect your spacecraft. I mean, it will be difficult and expensive, but you could use magnets to protect your spacecraft. I mean, right now, look at Vassima. That was the next one I was going to talk about. Ion propulsion. Well, the thing is, the future of electric propulsion is not going to be turbines, it's not going to be electric engines, it's not going to be iron because iron's far too slow, it's going to be plasma. Look at Vassima, V-A-S-I-M-R. Vassima basically uses, I need to look up an article on this. Alright, Vassima basically uses plasma. Now, in Vassima, they are developing plasma jets, basically. We already use plasma cutters and all sorts of things. I mean, there was some guy who made a plasma lightsaber that uses spinning wire or something on a stick that's heat resistant to create a plasma lightsaber. All right, variable specific impulse magnetoplasma rocket. Now, there's the other thing. Magnets. We need to research magnets. There is so much we don't know about magnetism. Did you know that bacteria use magnetism to detect the difference between up and down? I didn't know that. I just researched it recently. And did you know that all life on Earth possibly can detect magnetic fields, the magnetic fields of the Earth specifically? I mean, it's possible, it's believed that all humans have a magnetic sense, and that your sense of direction is actually your sense of the Earth's magnetic fields. And this could mean that you could train your magnetic field sense. I mean, I've been doing geography, but I've always been bad at it. And the thing is, one, I don't have the greatest sense of direction. I mean, it's not bad. It's just, I normally just look up and use the skies or my memory. And two, I'm just bad at maps. I mean, I've been doing an A-level for geography that I just haven't enjoyed because one, I don't enjoy human parts of geography. I really don't. And two, I'm bad with maps. I mean, one of the exam, I did maps, and I'd never done a past paper exam because I think they're making it, it's kind of a new thing. Actually, no, I think this was GCSE. So I'd never done a past paper exam for geography. And because of that, I only got a C. So I wasn't even supposed to be able to do it for A-level at my school because I go to a grammar school. It's ridiculous. It is so ridiculous that so many people are bad at geography when we should be doing so much to explore the underwater oceans or the different countries. I mean, you could have a treasure map thing where they give people the government could just have a treasure map thing where they give people free amounts of money just for finding things that they've hidden. I mean, why do we not have that? It's just so obvious. The government is not doing enough. The government is lazy. The government are full of idiots. They don't know what they're doing, and we need to replace them ASAP. Now, so iron. Iron is really useful for space. It will be used in space because, one, the current new generation of ion propulsion, one, it's extremely fast. Two, it has a long acceleration period because it has a low lift to weight ratio, but it's extremely fast once you get going. I mean, the current ions test has been going on for 6 years, and it would literally be going over 100 Mach. I mean, just think of that, over 100 Mach, that's 100 times the speed of sound. Actually, it was 128 times on the video I watched. Now, we need more research projects like this. We need more research on space propulsion. We need more research on fusion. We are so behind on fusion. I mean, obviously fusion costs a lot of money, but we aren't doing enough of it. There are only a few projects on fusion, and all of them are extremely expensive, inefficient, and based on the use of large magnets instead of magnetic lines, or using wires, or all these different things that we should be using. Because the thing is, magnetism is everywhere. Every chemical bond in your body between molecules is made of an electromagnetic bond. Every single atom in this world is connected into what we call particulates in a small sphere that's bonded together by that stuff where water droplets stay together. It's bonded by that, and then it connects to other particles into a molecule through bonding, and etc., until you have, an object, a speck of sand. Now, the future of Earth propulsion isn't going to be electric turbines. I mean, we don't have the battery technology for that. I think planes should use hydrogen at the moment. We don't have the battery technology to have enough lift to weight ratio to be able to fly planes with electricity. What we should instead use is extremely large capacitors in the wings, and then have a hydrogen engine on board, because you can just have the plane go down, pick up water, and just land on the ocean. Use solar panels to turn the water into hydrogen and oxygen, and then simply can take off again and simply do the process over and over again. I mean, it's not going to be that hard, and we could already do this. And the other option is to use, basically what I'm talking about, is to use iron. Now, iron has been proven it can take off. I mean, there was MIT scientists created an iron-propulsed plane, and that is, to me, amazing. I mean, they basically did what the Wright brothers did in a different way. They created a new form of propulsion. They did what Ford did, essentially. Now, it wasn't very good. It wasn't as fast as the Wright brothers plane. It had to be launched using rubber or something, but it did climb. It did raise and fly. It achieved self-propelled flights, which most electric and solid-state planes in the past, they were all connected by wires. So these solid-state planes will have to use. They simply aren't good enough. They will eventually come around. There will be iron in the future that will use quantum magnetic electric technologies that will allow for solid-state propulsion. But all of them will still use gas, and in space they'll probably use xenon, which is used for a number of reasons. It's heavy and easy to store densely, and is very good for storing for long periods of time. Now, in the future, what I think most electrical propulsion engines will be plasma. Now, Vasimir, basically, it uses ionizes with using an injection system, the gas, and then it heats it using microwaves and lasers and all sorts of things. And it uses a magnetic field, once it's ionized, because it's electrically charged, to propel it from the back of the Vasimir engine. And the problem with this takes a lot of electricity. In the future, it will probably need nuclear fuel. And the problem with sending that into space is that if it gets in the atmosphere, then you have a nuclear disaster. You have a nuclear disaster on the scale of Chernobyl or Fukushima. And you can't do that right now. I mean, one possibility is just to use something with a very low half-life, but like carbon-14, which has a very, very low half-life. It's like 2.5 years. But that will still cause radiation for 2.5 years, and a lot of it. Now, another idea is that they have to invent, is that they simply use hydrogen as a hydrogen fuel cell. But I don't know if that would produce enough energy, or if it would have to have an extremely large amount of fuel. I mean, it's possible, But the point is, it has a low weight to. It's similar to iron. It has a low weight to size ratio. But it does have a better one than iron, and it could get you to Mars in 40 days potentially, if you had enough of them. So one idea of mine is that they'll use these on basically on planes. Now there was already a test for this using plasma engines on planes, but the problem is for a normal plane you need thousands of them. However, for small planes you'd only need a few hundred, and they are testing this, and it will happen soon. You will have planes that use electrically charged plasma. Now I think the only problem with this is that hydrogen fuel technology, it's not as good as batteries, but it is very good. I think we need more research into it, and I think we need to find a way of storing hydrogen while it's a gas that's efficient. Because that's the problem at the moment, you can't store hydrogen as a gas either. So yeah. Now, back to colonies, let's say. We're going to talk about colonies now. Now, colonies will be like when people went to America. You'll have these colonies with settlements, and you'll have people living them. And you'll need at least 150 people, because all the villages in the past had 150 people, because that is the size of a human tribe, and it has been the size of a human tribe for centuries. I mean, the average number of friends, according to most sites, is about 150 people or so. And the reason for that is that your brain can remember about 150 people as your friends. It's just wired into brain. I mean, it's the reason why we beat the Neanderthals and Denisovians. We had larger tribes, and so when we absorbed them into our tribes and mated with them, they had less people who were there, and so less of the gene pool was preserved. I mean, that's why people in Europe have 2% Neanderthal DNA, because there were simply less Neanderthals, and in the cases where they did join our tribes, which were common, there were less of them there. There were only 20 people. There were less social people, less social human hominids. And Denisovians is probably the same. I mean, there is a lot of talk about how in Tibet, the reason the monks there can survive the harsh temperatures and the low oxygen is simply because they have DNA from basically these Denisovians. I mean, there is so much we don't understand, and there's so much that is missing from our society. So colonies will be the next step in going to space. You'll have colonies that are self-sufficient, and most of them will decide what they want to do. Now, obviously, I think if we have a Martian colony, if we have a colony on Mars, it will need to have at least 5,000 people, because that is how many people you need to have a self-sustaining genetic population. The thing is, though, we are modifying DNA. We've modified DNA in cats, we've modified DNA in dogs, we've modified DNA in jellyfish, we've made glowing cats, and we even have the ability to affect in vitro fertilization. We even have the ability to let people design their babies, basically, by simply choosing which cell is used, and then you can learn about what that baby will be like. I mean, there are a lot of ethical problems with this, but it's also amazing what you can achieve with it. I mean, imagine modifying it so your baby has no genetic diseases, and your children will simply have no genetic diseases whatsoever, and then simply doing the same thing every generation. You'll never suffer a genetic disease again. You'll never suffer Alzheimer's early. You'll never have a heart attack when you're very young. I mean, imagine being able to modify your DNA and then, well, obviously this would be harder once you're an adult, but modifying the DNA of your baby so that they have blue skin, for example. I mean, we talk about evolution, how people in space, when they spend several thousand years in isolation, they will eventually evolve to be different. But the truth is, there is no reason for that, because we can just modify the DNA ourselves. You could have it so that you have better eyesight. Neanderthals had larger brains, and most of that was geared towards their larger eyes. You could make it so you have the eyes as powerful as Neanderthals using Neanderthal DNA, for example. I mean, we could just find Neanderthal bones, extract the DNA in it, and recreate the Neanderthal. I mean, people say that the problem with the woolly mammoth is that bringing it back, it wouldn't have the food to survive. But we could simply create an artificial environment. What we should do is go underground, build an extremely large underground area using a national project, and then simply put all the herbs and stuff that the woolly mammoth ate, or redesign them again, and then simply bring back the woolly mammoth there using elephants, and then seeing what happens. I mean, you could bring back the woolly mammoth simply by slowly modifying the DNA of elephants. You could simply use in vitro fertilization to modify it once a generation. It'd be the same as breeding animals, but using artificial techniques to make it faster. I mean, You could even make apes more intelligent by modifying their DNA with in vitro. You could every generation make it so that their brains are more adapted, their social part of their brain is more efficient, more powerful. You could make it so their logical mindset is more powerful. You could teach them language. You could write it into their instinct that they know what language is, so that they don't need to learn English. They know it by instinct. I mean, you could modify human children so they know all Latin languages from birth using instinct. We just have to find out what instinct is. We still don't know. We still don't truly know what a lot of DNA is used for. And there is so much we could gain from this. So yeah, I think I'll just name this video futurism. Yeah, futurism. That'll be what this video is called. And I hope you guys enjoyed this. Please subscribe to my channel and comment below. I don't particularly care if you like the YouTube like system. It's kind of fucked. Although it's kind of funny that the YouTube Rewind is the most disliked video on YouTube. It even defeated Justin Bieber's video. So yeah, go dislike it now and hashtag go to space. Yared out.